All right, let's get right into it. Today, we're going to pull back the curtain on a super common, yet really critical mistake that even the best programmers can make. It's this silent bug that can absolutely wreck your code. And the funny thing is, the culprit is usually hiding in plain sight.
You know the feeling, right? Your app works perfectly during testing. You push it live, and everything seems great. And then, boom, it just falls apart. You've checked your logic, you've checked your syntax, everything looks totally fine. So, what is going on? What's the hidden bug that's causing all this chaos?
Well, here's the twist. The problem probably isn't in what your code does, it's in how your code is organized. Specifically, it's all about how you decided to structure your data. If you get that part wrong from the beginning, you're basically building your entire project on a shaky foundation.
So, let's dive in. The key to fixing this and preventing it lies in understanding how to properly organize your data. And that brings us to the hero of our story, the data structure. Now, this is way more than just a folder or a box to put stuff in. Think of it as a smart storage system, one that's designed to make your code run fast and, honestly, make your life a whole lot easier.
When you're picking a data structure, you've got two big choices to make right off the bat. First up, static or dynamic. A static structure is kind of like a bookshelf you buy with a fixed number of shelves. It's perfect when you know exactly how many books you have. A dynamic one, on the other hand, is like one of those expanding folders. It gives you the flexibility to add more stuff as you go.
Your next choice is mutable or immutable. A mutable structure lets you change things directly, like editing a sentence in a Word document. But an immutable one is more like a signed contract. Once it's created, it cannot be changed. If you want to make an edit, you have to create a whole new version. Now, that might sound like a hassle, but for complex apps, it can make your code way safer and more predictable.
And look, this isn't just some abstract theory. As the programmer Ivo Janč puts it, this is the absolute core of what we do. We're constantly taking real-world things and translating them into data. So how we choose to model that data is one of the most important decisions we make. Okay, with that foundation in place, let's look at the most fundamental tool in any programmer's toolbox, the array. So what in the world is an array? Well, the best analogy is a cupboard with a bunch of shelves. Each shelf holds exactly one thing. All the things are the same type, like, say, jars of spices, and they're all kept in a very specific order. You know that if you want the paprika, you just go to the third shelf. Simple as that.
Now, here are the essentials you've got to know. Arrays are typically static, meaning fixed in size, and they're mutable, so you can change what's on the shelves. You find things using an index, which is just its numbered spot in the line. And please remember this, it's a classic trip-up for beginners. The numbering, that index, it always starts at 0, not 1.
All right, enough theory, right? Let's see this in action and build something fun. We're going to use an array to put together a game grid.
So just think about it for a second. You've got the classic game of Battleship. It's a grid, right? A bunch of squares on the ocean. How would you actually store that whole layout inside a computer program?
The perfect solution is something called a two-dimensional array. It's basically an array of arrays. This creates a grid, just like a table. So here we've made an 8 by 8 grid, and we filled every single spot with a dot to represent empty water. Okay, now let's place a ship. We can go to any square we want just by using its coordinates, its row number and its column number, and then we can change its value. So here we've just placed a 3-unit ship by changing 3 of those dots into the letter S. And as the game actually gets played, this array becomes our living record. Someone fires a shot at a coordinate. Is it a miss? Cool. We'll mark that spot with an X. Is it a hit? We'll change that S to an asterisk. The array is the perfect way to model the game board because the board size never changes, and we need to be able to get to any coordinates super fast. It's just a perfect match. But what happens when you pick the wrong tool for the job? We're going to switch gears from a fun little game to a really high-stakes, real-world failure that shows just how serious the consequences can be when you choose the wrong data structure.
16,000. In 2020, that's the number of positive COVID-19 cases that were just lost by England's public health system. During a really critical time, they just vanished from the records.
So how on earth did that happen? Well, let's break it down. First, they used the wrong tool, an old Excel spreadsheet format that had a hard fixed limit on the number of rows. Second, the data grew way faster than expected.
As cases surged, the records blew past that limit. Third, and this is the scary part, it was a silent failure. The system didn't crash or show an error, it just chopped off all the new data. The result? Contact tracing was delayed, and that had massive public health consequences. All because a static data structure was used for a problem that was clearly dynamic. And this is exactly what computer scientist Steve Ferber is talking about. This is why planning is so important. It's not just about writing code that works right now. It's about designing systems with real discipline, thinking ahead about how your data is going to be stored, how it's going to be accessed, and crucially, how it might grow over time.
Okay, so we've seen a great example and, well, a pretty terrible one. Let's bring this all home and get you ready to start making these design choices on your own.
Here's a quick little cheat sheet for you. If you've got a fixed-sized grid and speed is everything, like our Battleship board, an array is your best friend. If you have a collection that needs to grow and shrink, like a shopping list or a to-do list, you want a list because it's dynamic. And if you need to look up data using a unique name, like looking up a player's stats by their username, a dictionary is absolutely perfect because it stores everything in key value pairs.
Look, if you remember just one thing from all of this, please let it be this. Don't just grab the first tool you think of. Really look at the problem you're trying to solve. Ask yourself, how is this data going to be used? Is it going to grow? How will I need to find it? You have to match the data structure to the job. And that's pretty much a wrap. So, I'll leave you with a question to chew on. Think about a problem you care about, or a project you want to build. Based on everything we just talked about, which data structure would you reach for first? And more importantly, why? Answering that question is the kind of thinking that separates good programmers from great ones.